Welcome to the demonstration video of my weather tool. How this tool essentially works as an introduction is the user, typically a designer, will use this tool to be able to generate weather easily in their project based on the kind of thing that they would need for the scene that they're making. They are able to choose, as seen here, between a climate, a season, the erraticism value, which I'll explain later, and whether or not they'd like a day or night cycle. First, a bit of explanation about the project. It's coded almost entirely in C++. I began by prototyping in Blueprints, but about midway, maybe just after, through the development process, I started rewriting everything in C++. The only things in this project that weren't written solely in C++ were the formation of this UI. All widgets were created in C++, and as was all their functionality, but the actual composition of the widgets on this screen was done in the engine. Also, I created my data table that I'm using for this project in the engine, and a couple of values are assigned in the editor. Other than that, everything was created in C++ and scripted by me. So what this tool can do, if you press on climate, there is a choice between this many climates. They all have different weather attributes. So for instance, we'll start with polar and winter. This would be used for a snowy scene. I'll show the data table in a minute, but essentially this would, as you'd expect, it would have a high amount of snowfall because of the polar climate, and because it's winter, it would also have a high amount of wind. These buttons also work to clear the selection if you change your mind. The erraticism value is used to determine how often the weather will change to a different state. So the weather changes dynamically in the scene because I didn't want it to just stick with one weather the entire time. I want it to sort of appear like real life. So during gameplay, the weather will change slightly to accommodate for different values for the precipitation or the wind. The erraticism determines how quickly it will switch between them. So a high erraticism value will make it switch between states much faster, while a low value will make it slower. For the purpose of this demonstration, we'll do it quite high so that it changes quickly, so that the changes can actually be seen. Finally, the day or night cycle is enabled by ticking this box, and the day length is determined here. A higher value will mean faster days, and a lower value will be slower days. This is because the value corresponds to the rate of rotation of the sun. The day length value will only matter if the day-night cycle is enabled. Without it, it won't make any difference. Again, for the purpose of this video, it will be quite fast just to show it working. Then, once everything is decided, you can press Generate Weather, and then everything should be set up. So the weather in the scene is contained in this volume. I made this volume myself in C++. Essentially, it has multiple components. It's got a brush component, which is built in. This is the cube that you can see on the screen. It also has Niagara components for the precipitation systems. So for the rain and the snow, these will show up when it is raining or snowing. And it also has a day or night component, which controls the day or night system in the scene. In the day or night component, the sky sphere and the sunlight need to be set from the world, for instance, like this, and then it should just work after that. We then have the data table, which is where the information for all the seasons and climates is stored. This is stored as rows of structs, which are seasons, as you can see here. The seasons structs are made up of maps, and the maps are made up of names and more structs for the climates. So, for instance, in Spring Struct, you can see the climate map here. You open it, it's got 5 elements. These are all the individual climates. And then within each climate is weather information such as snow minimum, snow maximum, rain minimum, rain maximum, wind, and these values are used in the calculations for the weather when it is generated. As I say, this now back in the scene, the weather can be generated. So as shown before, it is currently set to polar winter, and the day or night cycle is enabled, and it will move between states quite quickly. So first, we'll just display the regular weather. So if you press play, as you can see, the snow starts spawning. At the moment, the wind is relatively low, but it will pick up and then switch between as it moves on. You can also see the day or night cycle in effect. One thing that the day-night cycle does not include is a moonlight. So that would be something that the designer would have to implement if they wanted more light in the nighttime, such as now. But you can see the snow having spawned to match up with the season, and the wind does change as it moves along. The rate, the erratism value, and the rate of transition can be seen best in seasons that have both rain and snow enabled. In my calculations, I had to make sure that rain and snow could not be present at the same time, since this wouldn't happen naturally in nature. So an example of this would be in temperate winter. We'll set the erratism quite high again. This time we won't enable the day-night cycle. And then if we run the scene again, you can see it's snowing. The wind is significantly lower than in the polar winter because high winds to that extent is not something you'd expect to see in a temperate climate. Hopefully we should see the snow switch to rain. There we go. That was when the snow state ended, and now a rain state has begun. Rain is more common in temperate winter, so this should happen more often. As you can see also, the snow stopped while the rain spawned, because in nature the two wouldn't happen together. There is also functionality for no precipitation spawning. This will be most easily seen in climates with low or moderate to low rainfall, such as Mediterranean winter. Again, we'll set the erratism high. Weather has been generated. We can run it. So the rain is very low in this area, but you can still see it spawning on the screen. But there will be points where no rain spawns at all. Now I will demonstrate how 2 volumes can be present at the same time. To do this, I will first shrink the volumes. This is something I had to implement, was scaling of the weather, because I realized that if I was spawning the same amount of weather for small volumes and large volumes, the small volumes would be completely overwhelmed by the amount of particles being spawned. And it wouldn't look right. Similarly, very large volumes, even if the weather was high, it might not be visible because of the small amount that was actually being created in the volume. It would be very spaced out and it would be difficult to see. I can demonstrate this by making the effects visible temporarily in the volumes. So here's an average size volume. This is what I usually use for development. And then if I make a smaller volume, I'll drag this out here, and then I'll shrink it. You can see that the particles are spawning much closer together, even though the same amount of rainfall is happening here. They are much, much closer together in the small volume, simply because the same amount of particles are being created in a much smaller area. So I implemented a scaling functionality. I'm going to shrink down this volume a bit, just to show the 2 separate volumes. and we're going to move it over here. We'll go back to polar winter for this test because it's the easiest thing to see the amount of particles being spawned. Back to hieraticism, generate. And now, rather than generating the weather for just one volume, it should have been generated for both. So if we press play, this is the large volume that was present before. As you can see, the weather is spawning, and it looks the same as it did with the last test. So then over here, we have the smaller volume that I just created. As you can see, the snow is just turned off for this volume. That's because there is a random chance to have no precipitation with each weather state. But now you can see it's come back, and even though they both have high snow spawning, the smaller volume has far fewer particles than the large one, meaning that it's not being overwhelmed by the amount of particles. I will also show this in a season and climate with lower weather, so we'll go for temperate autumn to show that it works with the rain as well. As you can see, not much rain being spawned here, but it's the same quantity or the same amount appearance of raindrops as over here. That demonstrates the scaling functionality, which is very important for me to add. And finally, something that it's not especially easy to show on this demonstration, but I do have a functionality for softening the transitions. By this, I mean when a weather state moves from one to the next, it will find a midpoint between the previous precipitation rate and the next precipitation rate. Then it will set the precipitation to the midpoint before it moves on, which essentially just makes the transition between the two less harsh. It could use more refining, as most things in the system could, to make it more similar to real life, but for right now, it helps just make it a little easier. I'll try and demonstrate it with temperate winter. So you could see the wind change there. You can see that it will change between slightly faster and slightly slower. Sometimes it's hard to demonstrate this aspect of the tool. Yeah, as you can see there, the rain got slightly slower just before it transitioned into snow. The weather tool could in future be updated with more weather, more climates, more features. But for now, this is what the tool consists of. Finally, I will just show the difference in day length. So if I put the slider down here rather than at the top like it was before, when we run the widget, you can see the shadow is moving much slower than it was before because the day is lasting longer. For some final technical explanations, I will just explain how parts of the tool work. So when weather is generated, the weather selector will read the data from the data table that matches the inputs of the user. And then once it will calculate all of the weather it needs inside the selector, and then it will pass the values into the volume. How it does this is it will search the world for weather volumes, and then when it finds them, it will call a function within them to set the user inputs within the volume, and it will pass the values that it has just calculated into the volume this way. The volume will then set parameters for its components inside of itself based on the values this has just gotten from the weather selector, and then it will generate the weather that it needs. That's about it for the demonstration of the tool. Thank you for watching.